Good evening, ladies and gentlemen, friends and members of the Belgian section of the Royal Society of Chemistry, to our penultimate winter season lecture. This evening we're turning to a subject which has suddenly become, shall we say, rather sprung into prominence by virtue of the activities of a certain leader of a certain country at a certain distance, but not too far removed from Europe. I think I don't need to make any further insinuations. I think you can see what I'm getting at. I think we've suddenly realized that deriving energy solely from hydrocarbon sources, and in particular from hydrocarbon sources which come from a part of the country which turns out a part of the world that doesn't turn out to be particularly friendly towards its neighbours, is not a very wise way to do business. And I think a lot of people are now beginning to realize that we have to reconsider our whole situation with regard to producing energy. And this raises then, of course, the inevitable question of why not go back to nuclear, which is what, as we have seen in some very swift decisions on the part of the British government, is what the British government appears to have decided to do. So this evening, it's no surprise that we have invited as our lecturer somebody who is very much representative of the nuclear industry here in the EU. Andrei Goicea graduated in 2002 from the University Polytechnica in Bucharest. Sorry. Sorry.
No, someone else.
It's okay. Okay, right. From the Faculty of Power Engineering as a nuclear engineer, and from the Marketing and Foreign Trade Faculty as an economist. He's also got a Master in Nuclear Safety and Radiological Protection. And since May 2015, he's at FORATOM, currently holding the Policy Director position, having previously worked in the nuclear power industry in Romania. We are very much looking forward to your talk this evening on nuclear energy at the EU level, the current state of play, and its outlook. Andrea, over to you. If people could just please switch off their cameras and their mics. Thank you. Andrei, you have the floor.
Thank you very much for the introduction, and it's a pleasure for me to participate, and thank you very much for the invitation to present. As you were saying, nuclear is right now how to say gaining visibility. Unfortunately, I wouldn't say that the context is the wanted one. We were trying to say for a long time that nuclear, it's an option. It's one of the decarbonized options for the energy production. Now the reality, I would say, is showing that it's really needed these days, and I would be happy to provide you some more information about what is going on in Europe, focusing more on EU. And as you heard in the introduction, I'm a nuclear engineer. I have to admit I wasn't very good at chemistry. So please accept my apologies for this. But I would be more than happy, even my presentation, it will focus mainly on the policies and sometimes on economic aspects. I would be more than happy to respond to the technical questions that you might have. So please feel free to raise your hand, and I would try to respond to the questions. So having said that, I will start my presentation first of all to say some words about FORATOM. It's the trade association of the European nuclear industry, and it's the voice of the industry in the discussions with the EU institutions and the other policymakers. Our members, so we are an association of associations, so we have 15 national nuclear associations as members, not all of them from EU. We have 3 non-EU members, UK, Switzerland and Ukraine. And in some countries where we do not have don't have national association, we have some corporate members. Is the case for Czech Republic and Poland, and we have other corporate members interested to get more into the European policies. Key topics, I'm not going to get into details, but we have a wide range of topics trying to cover. We are a small team of around 11 people. I'm saying around because some people are leaving and some we are trying to hire new people. But anyway, it's around 11, 12 people. So with these resources, we are trying to cover a broad range of topics. We have some working groups and our members are helping us. But of course, the Secretariat is having also an important role in following different topics. And you can see that on nuclear technology, so on the technical part, we are active in innovation, research and development, but also in nuclear transport, supply chain, or waste disposal. Nuclear safety, it's another organization that it's belonging to FORATOM. What is the nuclear energy at EU level? And we are talking about big numbers, not all the time known. So I'm talking about from the economic point of view, we are talking about an impact on the economy of around 100 billion per year. And in terms of jobs, direct and indirect, around 1.1 million jobs, which are really a lot. The nuclear industry is a very localized industry, so we are not having equipment manufactured so much outside Europe. So that's why this industry is so important. And we are producing around constantly. Of course, this percentage will decrease, but for many years it was around 25%. Now with the closure of some plants, like the one in Germany, we are expecting this share to decrease slightly. This chart is showing what is the situation today. You are seeing here that it's a little bit different than the previous number because we are talking about 133 operational nuclear reactors in EU and FORATOM non-EU members, so Switzerland, UK and Ukraine. And you can see also the situation regarding the nuclear power plants under construction. So to be honest, I have to update because the one in Finland already started the operation recently, so it can be put already in operation. It was a big achievement. It was first of a kind of a new technology, European pressurized reactor, and as you can see, it's a very big. The size of reactor is it's very big. It's 1,600 megawatt. So I don't want to compare it with some windmills or some solar, but we are talking really about big numbers. In terms of share, as I said, 25% constantly. This was the situation in 2020. It was almost 25%, but it's an interesting thing here in this slide, and also it's having animation. It's having also the figure for 2021, where nuclear is the absolute champion of the power production in Europe. So it's the single source, the highest producer of a single source. You know, of course, you will hear in the news that renewables bypassed coal or gas, never nuclear so far. But when you are splitting on the particular sources of renewable wind, solar, or hydro, you will see that things are not getting. I mean, the renewables are not delivering so much. Hydro is constant. It's we are not. There is no expectation to increase the share, because developing new hydropower plants is quite complicated. It's in terms of licensing, impact on the nature. It's quite important. So basically, it will stay constant. Only the only other renewables, variable renewables, solar and wind, are expected to grow, and actually the bet of the policymakers is on those renewables. Bioenergy, it's a different story. It's also considered renewable, but at the end of the day, it's still producing CO2. And of course, we have other renewable technologies which are I would say not very mature for the moment. EU balance of powers in terms of nuclear, I would say. So you can see in this on this map in green, it's we have the nuclear supporters. Then we have, I would say, traditional nuclear opponents: Luxembourg, Germany, Austria, and Italy. Maybe we should change it in yellow, because there are some thoughts about new technologies, new nuclear technologies. And then we have some countries which are still considering their nuclear future, and Poland is one of them. It's considering for quite a while. Then Belgium, and recently Estonia is also thinking about it. And yeah, it should be Sweden. I just noticed is missing the pin there. There are some developments also from there. With the Brexit, we lost a big supporter in EU of nuclear, and as you can see lately, there are very positive developments on this sector in UK with a very good perspective. Very briefly, I will tell you some benefits of nuclear and how we are trying to present it, and what are the the main points presenting to the policymakers. So simply, we are saying, of course, it's low carbon. It's well acknowledged by everyone, but availability of 24/7. So we are talking about capacity factors of over 90% over the year, sometimes over 95%. So nuclear is a base load producer. And despite the fact that the development of new nuclear is considered very expensive, and it's true, still nuclear remain affordable, because we have to think about, yes, we have an upfront investment, but that investment will produce for 40 years or even 60 or even more, depending if the lifetime is extended. And we can see these days that there are a lot of lifetime extensions of the existing power plants, because after, of course, there are done the safety checks by the regulators. many of them are receiving the approval to continue to operate. And there are some very good examples, and this is showing the reliability of the nuclear technology. So now a little bit more information about the benefits. You can have here the comparison of the carbon emission, the carbon intensity per kilowatt hour of the different sources. We are talking about grams of CO2. So as you can see, nuclear is together with the renewables quite at the same level. Then I think this one is a very interesting chart, and it's showing let's say daily emissions in different countries. And you can see here that, for example, Poland over the year is having quite high emissions, daily emissions. Germany, depending very much on how the wind is producing, are ranging. So the emissions, daily emissions, are ranging from, let's say, 100 grams per kilowatt hour to I don't know, over 600. Italy with quite a high emissions, Netherlands, and on the bottom of this chart, you can see what is the average. You average where does it stand, and then what are the targets because we are talking about decarbonization on longer term, and you can see that only few countries can achieve this decarbonization with the current energy mix, and among them France and Sweden are two countries which are relying massively on nuclear. France the most. Sweden is having a very fortunate let's say a combination of hydro and nuclear. I was talking about availability, and you can see what is comparing with the other clean sources, the green ones. Nuclear is by far the champion. Of course, there are developments in the renewables, and this energy performance, I would say, is increasing, but will never reach such a level as nuclear. And in terms of affordability, exactly what I was telling you before, we are talking about high costs, upfront costs, investment costs, but then during the lifetime, nuclear can produce at a very competitive cost. So you can see that new build, it's quite comparable with solar and wind. While the lifetime extension, how we are calling, so basically the reactors, the existing fleet of the reactors, most of them had a design lifetime of 40 years. But as I said, after very detailed checks by the regulatory body, regulators from different countries, some of them were granted to extend the lifetime. And during this extension of the lifetime, because of basically the initial investment was already amortized, we are having very low electricity prices. So a lot of benefits coming from the existing nuclear fleet. What is the future of nuclear in EU? And I was saying at the beginning, even though nuclear is producing right now around 25%, is not really seen as having I would say a very optimistic future by the policymakers, and you can see what are the scenarios proposed by the European Commission. Of course, these were published before the crisis, the energy prices crisis, but also the war in Ukraine started. So the situation might change, but all in all, you can see that in 2030, the share of nuclear is expected to decrease, and even more would decrease in 2050. Of course, in 2050, we are talking also about actually doubling the overall demand. So the share is also impacted by this parameter. I'm not going to get so much into details, and I don't want to complain too much about how the policymakers are seeing nuclear. This is our job. This is what we are trying to make them understand, that nuclear should be part of the solution. We are not talking about 100% nuclear, but we hope to see at least at the same level of 25% of the electricity production in 2050. Some scenarios, we did our own analysis. I'm not going to get into details. We see a little bit different than the EU policymakers, and we hope that the scenarios will change in the future. Nuclear is part of the solution, and we can see that the role of nuclear can impact a lot of policy files currently on the table of the policymakers. And this slide is showing all the EU member states were supposed to submit national energy and climate plans. They did in 2020 and 2021, and there will be most probably a revision. I mean, there should be also a revision of national energy and climate plans. You can see that many of them are mentioning nuclear, but the plans beyond, because these plans are referring to 2030 perspective. Now we hope to see more, to have more information with the 2050 perspective, and this will help also the policymakers to change, let's say, the scenarios related to nuclear. Some developments at EU level with the impact on the nuclear sector. The most important, I would say, is this very important initiative of the new Commission started in 2019, the European Green Deal. Most probably you heard about it, and it's coming with different packages, and one of the most important is Fit for 55 package, legislative package. We are talking about targets, and what are these policy doing? We had some targets for 2020, and now we are setting the targets for 2030. We had set in 2016, 2017 targets for 2030, 40% for the greenhouse gas emission reductions, renewables 32%, and energy efficiency improvement 32.5%. But with this European Green Deal, we realized that in order to reach the neutrality, carbon neutrality of the EU economy, we need more ambitious targets in 2030. So now we are talking about at least 55% greenhouse gas emission reductions. So this is what is Fit for 55 package referring at, this percentage. And we will see also a change in the targets of renewables and energy efficiency. Just as a fact, what is right now the discussion about the renewable energy. The policymakers consider these days that the problem with the energy prices, but also the security of supply, can be solved with renewable energy. So more deployment of the renewable energies can replace successfully gas. I have some doubts, I would say, as an engineer, mainly because we are talking about mainly variable renewables. I told you that hydro, which can be a baseload renewable producer, have limited potential for future deployment, but variable renewables, and when the wind is not blowing, there is a problem. Of course, there are solutions like, or theoretically, there are solutions like batteries or hydrogen, but I'm not sure if they're mature enough to provide the solution for the moment. The decarbonization of EU economy, I told you in 2050 we have to have net zero gas emissions. So we are going to have some emissions, but we are going to have also some negative emissions, how we are calling them, carbon removal technologies, or land use and forests. And this is what should be in 2030. You can see that the target is 55%. What is important to keep in mind for this, I mean, it's important for the nuclear sector, of course, is the power sector, which is one of the first to be decarbonized in around 2040. So very big ambitions, and very well, a lot of challenges in achieving it. Yes, so one of our reports is showing that if we are not continuing to operate the existing fleet, of course, where it's possible, the emissions will even increase in the in the short term, short and medium term, up to 2030. So with nuclear, definitely the targets 2030, but also 2050 will be much easier, or is the only solution to achieve it. Some figures about how the 2030 targets can be achieved. I will not get into details, but it's an interesting analysis. Basically, as I was saying, the ambitions are increasing. So from 40% greenhouse gas emission reductions, we aim to get to 55%. The additional effort can be very easily covered by nuclear if it's if the decision is the correct one. And yes, I was mentioning hydrogen. Hydrogen is the buzzword these days in Brussels. It's the panacea. It will solve everything, but very very important. We are not talking about all the hydrogen. We are talking about renewable, or how is it called, green hydrogen. We had something to say, of course, because nuclear coming from the hydrogen produced by using nuclear electricity, it's also decarbonized. We cannot call it green because the color was already taken. We were assigned with the pink color. We didn't like so much, so we prefer more low carbon hydrogen. So, and the low carbon hydrogen, we consider that is really the way to do it. And I think that there are already some countries using it. And yes, the main point that we made on hydrogen, it was more on an economic one. It's based on you know, how fast you can amortize the electrolyzers, which are quite expensive these days. And of course, in order to amortize them, you need to run them almost the whole year. And for that, and of course, you have to run it on decarbonized electricity. There are some sources, and you can see what are the sources of green electricity. And of course, nuclear can, as I was mentioning before, is having a high capacity factor. So basically, it's the most suitable one. So this is the optimal functioning time for the electrolyzers. This range between 3,000 and 6,000 hours per year, and we consider that should be a combination with of nuclear with renewables. Some costs, I will not get so much into details, but they are very good forecast for the nuclear produced hydrogen. Nuclear and the nuclear energy and the energy sector integration. So nuclear is not producing only power, but it's producing also heat, and it's already used for district heating in some countries or for some industrial processes. But of course, new reactors like the small modular reactors, and I will develop the subject at the end of my presentation, might have an advantage related to the siting in producing producing more heat. Because mainly for the heat, you need to have the nuclear power plant next to the consumer, not far from the consumer, because heat can be lost if you have big distances to transport it. Excuse me. Desalination is another capability of nuclear. And of course, hydrogen, not only just from electrolysis, but for some advanced reactors who are operating at a higher temperature, they can produce hydrogen directly. Excuse me. So talking about the European industrial strategy as a whole, I will not get into details of this, let's say, more political initiative, but nuclear, beside energy, it's also producing or impacting many other, let's say, areas. Agriculture, health, very important, production of radioisotopes, but also space exploration. I was mentioning water desalination, but also food production and so on. Some figures related to the economic impact. So as you can see that what is the impact comparing with the other with some other sources, green or renewable sources, wind and hydro, and the comparison is done for 1 terawatt-hour produced. So what is generating for the economy? I was saying at the beginning that the nuclear industry in Europe is a very localized one, and that's why the impact is so important. And you can see that after constructions, nuclear is having quite a significant share in the impact. On the GDP. As you can see, some other industries, motor vehicles, you would expect to have a bigger impact. Well, not really, because a lot of the components are produced outside Europe. Some country examples: France, UK. What is happening there in terms of jobs? I'm not sure. I don't have the slide. There was a slide because we have the situation for all the countries, but you will be surprised that, for example, countries which are anti-nuclear or they are not having nuclear reactors on operation, like Italy or Germany, are having a very large or very important supply chain in nuclear. So even though if they are not operating, or they will stop operating nuclear reactors, they will still remain a very important player in the nuclear sector. Okay, I'm aware about the time, and I think that I have to speed up a little bit, if I'm not mistaken. Security of energy supply. Some comparison with other sources, so it's a very dense um, source of energy, uranium, and you can see that also the utilities are having some inventories that can fuel the reactors for almost 3 years. It's really the case because maybe you heard about in the current situation, some of the reactors, EU reactors, are depending on Russian fuel. For the moment, considering this feature of the nuclear industry, they don't have. We don't see it as a problem. These are the figures of where the uranium is coming from. I can see that I did the slide just before the meeting, and I realized that it doesn't have a title, but I have to add it. But you can see what are the sources of uranium. So it's quite a wide range, a lot of alternative sources. So I think that I mean, for the moment, we don't see any problem of potential disruptions in uranium supply. Yeah, this is a slide from coming from a report that we've done, and you can see that also nuclear can help, or continuing to operate the nuclear existing nuclear fleet will help in dependency, against the dependency on gas and coal. And as a matter of fact, this report was done in 2021 at the beginning, and these days we can already see some what is the reality, and what is the dependency on the gas and coal of EU. Energy prices, some slides about also very, how to say, hot topic discussed at EU level, and that's why we wanted to have also some slides and what is the impact of nuclear. You can see what is the situation these days. We can see a slight decrease of the prices in all the EU countries, but still they are very much impacted by the current situation. And yes, so the gas is one of the reasons, but also coal, and we still have a carbon price under the EU ETS. Is still very high. This is the problem because of the dependency on the different sources of the import of the different sources. So natural gas, 90% overall of the EU gas, it's imported, and then also you can see that coal is around 43%. Not to tell about oil and the petroleum products, but very high dependency. The gas, you can see that it's reaching high levels, the price of the gas, and it's impacting the sector. And I was mentioning also the EU ETS quite at a high level, over 80 euros per ton of CO2. While nuclear can help also in the stability of the prices, and this is because the price of the uranium of the source of the fuel is having the share is so the price of the uranium is 41% out of the whole fuel costs, and the fuel cost is 34% from the overall operating cost of nuclear. So all in all, we are talking about 15% impact of the uranium. So in the overall operating costs, that is not. That's why the prices, the production costs of nuclear are not fluctuating so much. And you can see an example of France, which is operating a lot of nuclear against other countries. Now, also a very hot topic for our sector, small modular reactors. I would say that the acronym is not helping very much. It can also it's a little bit confusing because it's also used for the steam methane reforming. But yes, we will see how we will develop this definition. All in all, the definition of these reactors are related to the capacity. So something between 10 megawatt and 300 megawatt electric installed capacity, but we can see these days that can go further beyond 300 megawatts. So we are still considering small modular reactors. You saw that the large reactors can be also 1,600 megawatt. They are having some good technical, how to say, concepts. There are proposed some new concepts for technical implementation of these modular reactors, which are helping in construction, but also the overall reduction of the costs and the delivery times. There is also, we have the category of micro modular reactors, which are under 10 megawatt electric, and for some industrial sites, this is more than enough and can help. Data centers, industrial sites can help a lot. Some features. So nuclear safety, we are talking a lot of new safety features, passive safety features. So no need for external sources of electricity to cool down in the case of an accident. In funding and financing, it's a lower upfront capital costs and can help also the private investors. It's suitable for the electrical grids, smaller electrical grids. Countries like Estonia, I was mentioning, is looking at, and the small modular reactor would fit perfectly. It is also, these reactors are very good also to replace coal, similar capacities, producing decarbonized electricity in case of small modular reactors. And human resources development is something that we are always keeping in mind when we are talking about competencies. Site supporting facilities and emergency planning, this is very important. So we are having a smaller evacuation zone because of the smaller size. So we can place them closer to the industrial sites, but also I was mentioning district heating. For example, Helsinki is thinking about having district heating done with a dedicated small modular reactor that can be placed nearby, and according to their plans, it might assure the need for the whole city. And also industrial involvement. We are continuing to to do things in EU and to help industrializing the European economy. This is the global map. It's I would say that it's a living document. I think it's from a document from 2021, from last year, but these things are changing. A lot of the technologies proposed here are in the early stages of the development, concept wise, but there are some which are making progress, especially in North America, Canada, and USA. Also in Europe, we have two, like the UK SMR, the Rolls-Royce one, but also in France, Newark. And in other parts of the world, they are doing also some progress. In terms of timing, because most probably you would be interested to know when are those reactors expected. In Europe, those are the ones who might be deployed based on. I'm saying this based on the memorandum of understanding signed by different companies. So we have NuScale and a boiling water reactor, BVR X300, developed by GE Hitachi. And then we have the UK SMR developed by a consortium led by Rolls-Royce. And then we have the Newark, the French design of EDF with other players from France. And you can see here, when I'm saying small modular reactors, I'm referring also that we can have multiple modules, but also that the reactor can be produced on site. Or in a workshop and brought on site. So it's that's why it's small. It's called module. And we can have a single unit like the BVR X300 and Rolls-Royce SMR, but also multiple units, so up to 12 in the case of NuScale, and 2 for the French design at Newark. What are the forecast? What is the forecast for the SMR deployment? You can see also some figures from our report that was mentioned also in some previous slides, and you can see that in purple we have some forecast for the SMRs in generation 4 reactors, the advanced reactors. The generation 4, I should say, because I know the figures behind, they are not so much. Mostly the figures are referring to SMRs. So you can see that there is a share, but the biggest share is still held by the large reactors. And I think that with this slide, I finished my presentation. Sorry if I miss any question. I didn't see any hand raised, but please feel free to let me know if you have questions.
Thank you very much, Andrei. I'm sure we're going to have questions. We'll do as usual. If people can signal on their... Boo is already leaping in here. Can we go directly to Boo, please? Boo?
Yes, I'm trying to put on the video.
There you are.
Yes, I have, well, 3 things on my mind. The first thing is that, I'm Swedish, so I follow a little bit what's happening in Sweden. And I was surprised to see that you hadn't put a green mark on Sweden, because the other day I read about a Swedish company, Kärnfull in Gothenburg, who is financed by a company in the Middle East, and they are developing SMRs and they are contacting the local councils in Sweden because they think that the future clients will be the local councils from the district heating and the electricity point of view. And they said, if I understood correctly, that they had already sold some units to Canada. But I might have misunderstood that it was SMRs that were sold to Canada and not from them.
I think that you are referring to this BVRX 300 and the capabilities of developing in Sweden. As far as I remember, because I saw the news. All in all, yes, we always consider Sweden that should be in green related to nuclear, but unfortunately, I should say that at one point there was about the policy and what was going on in Sweden related to the politicians and how they were seeing that they were not
like in Belgium, yes.
like in Belgium. So you are right. I will definitely update the slide, but I will put a yellow one. So it's still under assessing.
Another comment was that they calculated that the cost would be around 35 euros per megawatt hour. So they said it would be lower than wind reactors at sea.
Wind turbine. Yeah, it's because you mentioned if it's used for district heating, indeed. I mean, the efficiency is very high, and it can reach this price. If it's about electricity, to be honest, I would be cautious because we are talking about a lot of marketing. But of course, it's about business model. It's about a lot of things, and the biggest problem for the large reactors and for nuclear in general is it's the interest during construction and the high cost or higher cost because of this. You know, we are talking about 7 to 8 years at least for the construction, and during this time the cost of capital are very high, you know.
Yes, but they said that the idea behind this, as you mentioned a little bit about modular, that the units are mass produced in factories and then transported and assembled on the site. So that would bring down the unit cost very much. It's more like a prefabricated house that comes in modules that are assembled.
But I mean, it's totally right what you are saying. But now the problem is, and as I was also pointing, is that nuclear is a very localized industry. If we are going to produce the modules elsewhere than Europe, then the industrial advantage of Europe is kind of lost, you know, on this. So it's something that we are looking at. It's a little bit more complicated, and it's also a matter of licensing, you know. Of course, it was given the example of the aviation. Once you have a plane license in one country, all the other regulators are accepting that license. It's not really the case in nuclear to come to such a harmonization. We are talking about 27 regulators in EU. Each of them might have different opinions. So, but I mean, I don't want to be pessimistic, but of course, I want rather to be realistic and to try to look at the broader picture.
When I heard the word small modular reactor, after reading that, I understood the modular because they said that it's much easier to modulate these units for different capacities than normal nuclear plants.
No, this
to adapt
is,
to wind
no.
or
yeah, it's well about the flexibility of nuclear. It's clear that from technical point of view, it can be done. I mean, it can be done, but then the business model, and if you are considering a reactor which will perform load following, helping the renewables, then you cannot how to say you cannot amortize the investment like considering it as a base load production. So. But yeah, the modularity is coming basically from having modules, as I explained, not really modulating flexibility.
But then we come over to a next reflection to produce hydrogen at nighttime, because if you can't modulate it, it's a little bit like the street or the motorway lighting here in Belgium that was very cheap because the electricity at night was low. And if you use it at nighttime to produce hydrogen, it could be a good way of storing the energy.
According to the policymakers, hydrogen is not seen anymore just as a how to say as a solution for the variability of renewables, just to to how to say to help when the renewables are not producing. No, it's hydrogen is used these days in many industries, and this right now is produced mainly from gas, from fossil fuels. So that one should be replaced in order to achieve the decarbonization. But also we are talking about new processes, industrial processes that can intensively use hydrogen. And for those processes, sometimes it's needed to have continuous production of hydrogen. You cannot rely only, we will have a surplus of wind, we will produce now 1 ton and then the other day. No, we are talking about continuous. If we want to be serious, of course, if we don't want to, if we just want to use on small in a small scale, this is another story.
Right. Okay. Well, maybe we can move on to other questions. We come back to you later because I don't want to just monopolize everything. Could you go to Mike Kieran, please? Mike? Hello? Mike?
Sorry, I was muted.
Oh, you're muted.
Okay. Right.
You're on mute.
I've read in New Scientist magazine of nuclear power units using the heat generated from nuclear waste. Apparently, power units the size of a shipping container can power a small town. Like in this respect, the reactor's passive. Can you comment on this?
I'm not sure what. So from nuclear waste,
you get heat.
Heat,
from
yes.
Nuclear waste, you get heat, and you use that heat to generate the power or local heating for a small town. Mm-hmm. And they actually use nuclear waste, so it's a win-win situation in a way.
No, definitely the fuel. So after the fuel is in the reactor, is having a residual heat, and that's why it's the spent fuel is it's stored in a spent fuel bay, water cooled, and but this is the normal process. Of course, we are talking about very high irradiated materials. You know, it's a high radioactive field, and in principle, in theory, what you are saying that that residual fuel heat can be used for some purposes. But to be honest, I think that it's pretty challenging because we are talking about very the radio protection measures are at such a level that it might not make it, I would say, feasible. But in theory, yes, it's. But it would. If you can share with me, you'll have at the end of my presentation my email. If you can share it with me, I would be happy to take a look at.
Okay, I'll send you the New Scientist details.
Thank you very
thank
much.
you.
Thanks very much. David Terrell, please.
My questions are, I've got two questions. One is that nuclear reactors are very often sited on the borders between states. We've seen in Ukraine 2 nuclear reactors being targeted by the invaders in Ukraine. And this creates a situation of jeopardy for the inhabitants and for the world, in fact, because if they are, in fact, targeted, then you have the possibility of a dirty bomb. The second question I've got is about thorium reactors. You've made no mention of thorium reactor technology.
Yeah. Regarding the first one, of course, we were following closely the developments in Ukraine, and especially with the nuclear power plants, as they are our members. And you can see on our website, on the FORATOM website, we have a page dedicated to this. And yes, we are trying very much to take the information from the very trustable sources. And here we are talking about IAEA, which is an UN body providing this kind of, very trustable news. I'm coming from Romania, which is a neighboring country of Ukraine, and we felt the Chernobyl disaster, being so close, it had a very big impact on that. And of course, we heard about all the news coming from Ukraine these days, both in Romania but also in other countries, are very, I would say, emotionally sad. First of all, it was the news about taking over Chernobyl site. Yeah. As I said, I've been there in 2019. I visited the zone, the exclusion zone, and the nuclear power plant. And I was wondering, when I heard the news, why they would go there. And yes, it's the question about dirty bomb, about the waste that is there. But Russia is having really a lot of waste as well. Why to go to Chernobyl? And then the response was that mainly because Chernobyl was on the way to Kiev, coming from Belarus. It's on the main way, and it's also very emotional. A very emotional news. And then the operating reactors, we were, as I said, following closely the developments. And I think that, first of all, the technology, it doesn't, even if it's something is going on, I mean, it's hit by some rocket or something, depending on the size. Most of the new reactors or the reactors which are on operation had this assessment done, especially after post-Fukushima, of potential threat. And also one of the threat was being hit by a commercial airplane. And most of them were taken into account. So you can see what is the level of safety and how the risks are assessed for this installation. So we didn't see issues, but the news were presenting quite in a dramatic way. And yes, everything what is going on there is definitely unfortunate. But when we are talking about nuclear, I think that for the moment, the situation is stable.
Right.
And yes, the second question about it was about the thorium. Well, it's something that is there was taken into account by some developers, considering the abundance of or the availability of thorium, but in terms of technology developers, most of them abandoned this how to say this fuel, mainly because it's considered that it's having some challenges from the point of view of the safeguards, and that's why now uranium is the one considered. I cannot say more because, to be honest, not even at the university. To be honest, I've been presented so much. I know that, and sometimes we hear some news, but not so many developments. And it's also about. I assume that it's also about economics these days, because once you have such a developed uranium part, it's a little bit hard to switch, you know.
Okay.
Thank you.
Can we go back to Bo if you have your third question? Bo, you're still around?
I'm still around.
Have you still got a question you want to ask?
Yeah, or yes, or a remark.
Okay.
The main supplier, as far as I know, of uranium in the world is unfortunately Russia. No?
No.
No.
The
Okay.
main, I mean, I can take a look on the figures, but these days Kazakhstan is it's a very important player. I don't know, yeah, if I have the main figures, but there is the Euratom Supply Agency, which is providing the figures annually, and they are doing not only for EU, but also in a broader way. I'm trying to find the figures, but I cannot find for the overall. Anyway, yes, but what was the remark regarding, or if you'd like to add some?
That we are once again in the hands of what Russia wants to deliver us.
No, but as I was mentioning, we are talking about not a big market, but the alternative of the suppliers is quite important. Canada, it's a very important one. Australia, then I mentioned already Kazakhstan, Namibia,
Niger.
Niger, yes.
Yeah.
Nigeria, yes. So, and this the supply is fluctuating, and we are talking about reserves of the operators of fuel, but also reserves in uranium of some different countries. So it's not seen as a threat comparing with other sources, definitely.
Thank you.
Thanks very much, Bo. Thanks to the other two questioners. If there are no other questions, I just want to throw in one last little question. We mentioned this very briefly at the beginning. Do you think that with the developments that we're seeing now in Ukraine, and with the recognition of most parts in Europe, many countries in Europe, that they need to start reconsidering the balance of where they get their energy from, that nuclear can overcome some of its handicaps, which seem to have prevented it being so successful in the past?
Yeah, the question is how can nuclear what can nuclear do in this? And of course, we don't want to see this very unfortunate situation as an advantage. It's not. We are there. Nuclear is there. It's a reliable source of energy. What we can do and what can the policymakers do is to allow and to promote the continuation of the operation of the existing fleet, of course, where is fulfilling the safety requirements. And of course, for the new build, there are some that are gonna start operating soon, but it can, nuclear is the long-term developments, the long time of development of a nuclear power plant cannot. We cannot come with a solution in a couple of years. It's a way of decision. But of course, yes, it's on longer term. Maybe the overall strategy of EU should be rethink, and yes, nuclear should have a more important role on that, because of course. Having nuclear in this forecast will help also or incentivize the investment in nuclear. That's clear.
Okay, good. Thank you once again for a very interesting talk. Some good discussion, and we'd like to thank you on behalf of the audience. And we have I can assure you, will receive a small token of our appreciation, which we hope you will enjoy sampling.
Thank you very much. It was a pleasure also for me. And any question you might have, I will send you the presentation in the PDF format, and you have my email. And if you have additional questions, please feel free to contact us.
That's very kind. Thank you very much indeed. And I remind our members and friends that we will have another talk before the end of the winter session, which will be in May. It was advertised at the beginning of the program. Watch the website for the lecture, the interesting lecture on developments in cancer chemotherapy, and notably in the development of a new discovery made in the University of Louvain in Belgium here, which throws some possibility in handling the major problem of many cancers, which is the problem of metastasis. Thank you once again, Andrei. Thank you all for joining, and I wish you a very good evening.
Thank you.
Thank you very much. Bye.